Okay, if you got the software, you load your data, the starting page is this one here, which is the equipment that we have. This is the specimen, and you measure the length by finding where this one start to go straight, right? So you probably use the caliper, find from here to here, then you record it. And we want you to just simply click through this tab on the top. The second part is the theory. We kind of mentioned the theory already. I'm going to skip this tab. The next thing is the setup, which is what you did in the lab. We try to find what is the range when you actually start to pulling it in the sweet range from the 10 to 20 millimeter per minute, right? So you did that in the lab. And you can use this one as the procedure, a part of the procedure in your lab report. Over here is the procedure that you're actually pulling it, and how do you apply a preload, right? The preload is try to make sure that things is sitting in between the clamps in a stable position. Otherwise, when you're pulling it, it probably still wiggling and try to find where is it's fit into the strap. So the preload, make sure that everything is sit in a very stable position, and you can start pulling it, and you can record the response. Okay, now after this, you go look at your data. So this is the data from one of the groups. Analysis, he shared this data with me. So one thing you can do is that you go to the data summary, click on this tab. If you didn't change the color, you might want to change the color. So the color will represent different specimens. So if you didn't do that, you might want to do that so you can see which one is which. On the right-hand upper corner here, there's a legend window over here. Try to move this one such that you don't block the picture of this one, or you can use this hand. Simply use the mouse to move it, right? To move it to the right position. This is one of the graphs that you should include in your report, okay? You should have this one in that report. So as I mentioned to you, if you want to find the ductility, which is defined by the change of the lens. How do you find the change of the lens? The position here is the lens. So you want to find the final point to get this value in x-axis. That will be your final lens, which is actually the delta L. Okay, that is the delta L. And then you use that to divide by your L0 and times 100%. That is the ductility that you define percentage elongation. Okay, any question about this? Okay, let's move on to the next one. Okay, this is the main thing that you have to do. Over here, I give you some description how you are going to use those tools over here. The most of the tools you're going to use are here. Okay, so starting, we say, oh, you can click on this triangle icon, which is this one here. And this one allows you to select which material that you wanted to investigate. You might want to start with the first one by deselect the other things. Otherwise, all these things will be covered with the rest of them. So for example, if you click on this one, which is the brass, then we start to analyze the brass. If you have the one that was the original brass testing result, which comes with the software, you might want to use that to compare with your result to see if your result is very similar to their result, which it should be. You should have the very similar shape. The height may be a little bit different, but the shape, the overall range, it should be very similar. So first thing, you select the material, and then you can add annotation. Well, in this case, because there's a legend over here, you might not need to add that. But if you wanted to, you can make the legend by using this A to put an annotation. Some of the annotation that you might want to add is the fractional load, which is right over here, right? This is the force versus the position. You also need to find the value. So where is the one that you can find the value? This one, I think is, yeah, so this one is coordinate tool. With this one, that you can find the value at a certain point. So let's say I want to find this point here. Now, sometimes you want to see if you actually select to the point, you can use the mouse, use the scroll bar to zoom in or zoom out. So I'm zooming here, and I want to try to see where is the point. So this will be the last point. So this will be the point I want to find out. And you can see this is 0.00449 meter. Okay, remember this unit is in meter. When you divide by your L0, the original length, you have to convert it into the meter if you wanted to use this value. And that will give you the percentage of ductility. This one is the fractional load, but it's not fractional stress. Stress is different from the load. The load divided by area is the stress. So don't use this one to be the fractional stress. This is the fractional load. Okay. Any questions about this? So I find out that the mouse actually did a lot of things, including to move around. And you can also change the range by putting the mouse to the bottom, up to the side. Scroll up or scroll down will make the range to change. And if you want to see the zero, you just simply use the hand to drag it such that you can see the 0 point, the origin. The rest of the thing, I think you can see it, you can read it by yourself, and how to get the energy, which is a resilience, and also the toughness, and you can use this one to find. One other thing that you need is the window. So I think this one is the window. So this one is the highlight region, is the window that you wanted to find the value. So I said you can drag the window to change its size, to change its height. The starting one that you want to find is the linear region, right? This is the linear region. You want to find what is the Young's modulus. How do you find the Young's modulus? Once you select the window, and there's several icons will pop up. This one, I think, is called the curve fits. When you click on the curve fit, because it's a linear, you use the linear fit. Once you select that, and it will give you the linear. So this linear fit represent under this window, what is the linear fit is going to be. The first value here represent the slope, right? This is a slope. And this one is the interception, meaning you are not starting from 0 Newton. Somehow this data doesn't start from the 0 Newton, and which it should start from the 0 Newton, or start from the preload, which is 100 Newton. The R value represent how linear the line is. You are looking for the line where the R is close to 1. The closer this value to 1, meaning the better the result that is. You can try to change the size, see if you can get the value to be a better value. Like this one, I increase, doesn't give me a better value because R is getting smaller. And you can move this to see if the value is better. See, this is a 0.0999. This might be a better value. So that's how you find the Young's modulus, or the modulus of electricity. Okay, any question about this? Once you find that, then you go to the left-hand side, and there's a calculator. When you click on the calculator, and you should enter the value of the E. The slope is the E, so you're going to put the value over here. And notice the unit for this one is MPa, is the 10 to the 6 Pascal. Well, this one is not Young's modulus anyway. This is just the force over position. This is not stress strain. Young's modulus is from stress strain. So you're going to enter that over here. Let me go to the stress strain. So you, this is the most of the thing you have to do. Right now, when I go here, nothing shows up. What happened is I probably didn't select any of the material. So here, you're going to select the material. I'm going to select, let's say, aluminum. Okay, I select the aluminum. Aluminum shows up, and I only see this part of the material. So you can change the range. This will be the range of the stress. I'm going to change the strain. Move your mouse to the strain, to the x-axis. Use your hand to drag it. So get a good picture of what material being pulled under the strain curve. I want to see the overall. So, okay, this pretty much is overall now. Everything starts from 0, 0. I have a legend over here. I have my curve. Everything fit into one window. Then you can make a copy of this window and just copy this one to your report. And here, there's a linear region. This one here, 52200, is your Young's modulus. This is in MPa. So that's a big number. That means the Young's modulus actually in the gigapascal. So if you want to compare your result with the result that you can find from the internet, then you compare this value with the value from the internet. And this is a R 0.998, which is pretty good already. Okay. All right, any question about this? Now, the rest of the thing you're going to follow through, which is the yaw strains. This one is the most difficult one because you have to find a line, which is a 0.2%. I'll let you guys try to explore, and I will try while you guys are doing the things. Then, and if you guys can figure it out, that would be great. If you couldn't, then I try to help you on that one. The tensile strength is going to be what? It's going to be the highest peak. So sometimes it's hard to find where the highest peak. You have to enlarge this to find where the highest peak is. The toughness is the area. So how do you find the area? This one, this icon is the one that you find the area. Okay, then but you have to select the window. You have to select the window to specify what is the range you want to find the area. Okay, so here is one of the summary table. It's very similar to the table that we have. So if you finish this, then you should have this table in, well, our table has additional information. So you wanted to include those information in the lab report. Okay. Any question about this?
Do we answer these last questions? Yeah, these last questions, we got to put them in the lab report, right?
Yeah, put these in your analysis, or yeah, put this answer to the analysis board.
Okay.
All right. Any question for this? Okay, we're gonna make this one a little bit easier for you guys, so and also easier for me, so I don't have to grade the same report from the same group. In the lab, you did the lab together. If you work on the lab together, then you two can just submit one report. So just turn in one report, and you guys are going to get the same grade for this.